Okay. Good afternoon, students. In the last class, we discussed about the isolation and the concentration techniques of the what methods in the metallurgy. Okay, in that concentration method, we learned four types of different methods, that is hydraulic washing and the magnetic separation and also froth flotation and also leaching. And leaching is the chemical process, remaining or the physical process. Okay, and next one is, in that also we already learned the isolation techniques of the metals, or isolation of the metals from the respective concentrated ore. So in that, two types is there. One is conversion of ore to oxide and reduction of oxide to the metal. Of ore to oxide, we have two types. One is calcination, another one is roasting. What is calcination? Means the heating of a concentrated ore in the limited supply of air or in the absence of air, that is called as what? Roasting means the heating, the strong heating of the concentrated ore in the presence of a regular supply of oxygen, then it is called as roasting. Okay, last class we discussed all this. Today I am going to tell you what are the thermodynamic principles. Okay, thermodynamic principles involved in this extraction of metals. Okay, so thermodynamic principles in metallurgy. So the main thing here we follow is delta G is equal to delta H minus T into delta S. What is meant by delta G? This gives free energy. Okay, delta H means change in enthalpy, that is heat. Okay, and delta S means change in entropy, and T means temperature mean. So this is the equation. Delta G is equal to delta H minus T into delta S. So what we will came to know by this reaction? So one condition we know already. If delta G is negative, then the reaction is feasible. If delta G is negative, then the reaction is feasible, means that is stable, as it can occur. Okay, next. If delta G is positive, then it is not feasible. It requires extra energy to done the reaction. For example, so this is spontaneous, this is non-spontaneous. So without any external force, this reaction takes place when the delta G is negative. Okay, so if delta G is positive, that results in what? This reaction requires some amount of extra energy, as something we need to apply on that reaction to conduct. Okay, so using this reaction, listen, this is called as what? Ellington diagram. Ellington diagram. So this is the very important diagram which we use to identify which metal is suitable to the respective metal we want. Okay. So this is the Ellington diagram. It has some application, it has some drawbacks also. Okay. I'll explain that. So this is what thermodynamic principle. Why we require the thermodynamic principle? What is the need of this delta G is? I'll show reactions. Okay. So listen. Iron plus oxygen combine together to form FeO. This is a feasible reaction. So listen here. At the zero temperature, at this diagram, for this Fe plus O4 gives rise to FeO. Okay, I didn't balance, so here I already balanced. To this, the energy of this is, or a delta G value is minus 450. Listen, this is in between is 400 and 500. So delta G is equal to minus 450 kilojoules per mole. So this reaction is feasible. If we want reduction of metal means FeO decomposes to what? Fe plus O2. If we reverse the reaction, then what happens? Delta G, if it is negative, becomes positive plus 450 kilojoules. So now I am telling you the reduction of metals. So thermodynamics which are involved in the reduction of the metals. Okay. So listen, this is the reaction we came to know. From this it has approximately 450 kilojoules per mole energy from this Ellington diagram. Okay, so Ellington diagram in curve idalva Fe plus O2 gives rise to 2FeO, that is in between 500 and 400. Adra madhyadalli ide. So that is approximately what? 450. Okay, 450 kilojoules per mole ಅಷ್ಟು ಅದಕ್ಕೆ delta G value ಇದೆ. So then ಏನಾಗುತ್ತೆ? ಇಲ್ಲಿ delta G ಇದೆ ಅಲ್ವಾ? Fe plus O2 gives us to FeO. It has the delta G value 450. ಇದಕ್ಕೆ 450 kilojoules per mole ಇದೆ. So ನಮಗೆ ಏನು ಬೇಕಾಗಿರೋದು metal ಅನ್ನು reduce ಮಾಡಬೇಕು. We want to reduce the metal. So this FeO decomposes to Fe plus O2. Okay, this reaction is reversed. Okay, so in the thermodynamics in the last first year PU we studied if any reaction is reversed, then the negative delta G value becomes positive and the positive delta G value becomes what? Negative. Okay, so if the above reaction is reversed means delta G value is plus 450 kilojoules. Okay, so in that, so this reaction is easily not feasible because its delta G value is very high at 0 degrees Celsius. Listen, at 0 degrees Celsius its value is minus 450, so it is plus 450 for the reduction is not feasible. So in that time we have to choose one of the metals or any another curve which is just below that item. Okay, listen, why? Because whatever the delta G value is more, if Gibbs free energy value is more compared to any other metal, so that metal reduces remaining all the oxides. So for example, listen, if here magnesium has 1100 kilojoules per mole of delta G value. For what? Magnesium. So this magnesium can reduce this aluminium, zinc and whatever the elements which is just above this magnesium, it reduces all those in 0 degrees Celsius. Okay, so in 0 degrees Celsius, magnesium reduces all the respective metals which are present just above the magnesium. Okay, here above magnesium for aluminium also there, so magnesium can reduce aluminium. Here zinc is also there, so magnesium can reduce zinc, and iron is there, magnesium can reduce iron. Carbon is there, magnesium can reduce carbon. But so listen, here aluminium is at 0 degrees Celsius, aluminium has the delta G value minus 1050 kilojoules per mole. So here what happens? The delta G value for this magnesium is high compared to this aluminium. Okay, so here what happens? This aluminium has the capacity to reduce the elements which are just above the aluminium. Means it can reduce zinc, carbon, iron, copper, but it cannot reduce this magnesium. Why? Because so magnesium has the more capacity to react with oxygen. So what is meant by oxidation? Means listen. So if we get FeO, it combines with carbon means it forms Fe plus CO. Or 2FeO, 2 carbon means 2Fe plus CO2. This is the reaction. Okay, so why this carbon combines with oxygen means, listen here, C plus O2 CO2 has more negative Gibbs free energy. Okay, it has high Gibbs free energy compared to iron. So here iron at this temperature. Okay, that's why what happens? This is feasible in case of iron and carbon. Here also Aluminium is there, magnesium is there. If you want to reduce both of them, so listen, magnesium is there, aluminium oxide is there, assume. Okay, you want to reduce that means it will form MgO plus 2Al. At what condition it will form? Okay, this will happen when this negative value, delta G value of magnesium is less than aluminium. Understood? So this is not feasible at 0 degrees Celsius. Why? So listen, magnesium is there, first I write. This is not feasible, this is wrong. Because, so listen, here 4 by 3 Al plus gives rise to 2 by 3 Al2O3. Okay, here its reaction or delta G value is, here its delta G value is minus 1100 1050 kilojoules per mole. Okay, just listen why it is not feasible. I am telling. Is Mg gives rise to 2 MgO. Here delta G value is minus 1100 kilojoules per mole. So here what we want, we have to decompose this Al2O3 with this magnesium. So this reaction is reversed. Okay, just listen, we want the reaction, this Mg should reduce Al2O3. This reaction we want. So Al2O3 is in the left hand side. So this reaction is reversed. Understood? Okay. Therefore, this is equation 1. This is equation 2. Equation 1 is reversed because we want Al2O3 in the reactant side. Okay. This Mg is it present here only because it is already in the it forms Al plus MgO will get this one. Okay, but now I am doing the delta G value. Here the reaction reversed means it is 1050 kilojoules per mole. Okay, here magnesium is there means that is 1100 kilojoules per mole. So finally we get minus 50 kilojoules per mole. So this shows what? Here magnesium is there. Magnesium has highest delta G value, so it has the capacity to reduce aluminium. Okay, so this is one should suggest why the elements present lower in the elegant diagram reduces the above metals. Okay, next, and take same example, students, here for why it is not feasible. Okay. We have to check at 0 degrees Celsius this aluminium whether it reduces magnesium or not. Okay. So for that we need aluminium plus O2, that is 4 by 3 aluminium. O2 gives rise to 2 by 3 Al2O3. Delta G is minus 1050 kilojoules. Okay. Next. We want we have Mg plus O2 gives rise to 2 MgO. Its delta G value is minus 1100 kilojoules per mole. So here the final reaction we require, aluminium reduces magnesium oxide. So magnesium oxide we want, that is MgO, reduced by what? This aluminium. Okay, so here what happens? The reaction changes to Al2O3 plus Mg. If you balance again, this is 2, this is 3, this is 3 Mg. Okay, whatever may be the reaction here, I'm just assuming delta G value here. Okay, so here the reverse reaction is this one, magnesium. Here in the left hand side magnesium plus O2 is there, in the right hand side MgO is there, then it is minus 1100 kilojoules. When this reaction is reversed, because MgO we keep in reactant side, then it becomes plus 1100. So this will 1050. So it has plus 50 kilojoules per mole. So this plus value and minus value shows what? So this plus value shows if delta G is positive, I cannot feasible. Okay, it requires some amount of energy. At 0 degree temperature, so 0 degree Celsius, it never be, the aluminium never reduces magnesium. Only the magnesium reduces iron. So this is the example or proof. Understood? So similarly, this type of application is taken for iron also. Okay, I love this. And I know another example you will come to know. I think you may clearly understood this. This is very important, students. Based on the silicon diagram regarding what I am explaining now, you'll get 2 marks question. Write the reactions or a reduction of iron or extraction of iron using Ellington diagram. This is 2 marks important questions. Okay, now I am explaining. So consider these 3. 1, 2, 3. Okay, in that C plus O2 CO is there, C plus O2 CO2 is there. Here carbon combines with oxygen gives rise to carbon monoxide. So in that, first consider at 0 degree Celsius, this is the iron gun, this is the carbon monoxide. Correct? Or you may also take this one, C plus O2 CO2. This curve also you may take. Okay? So here, listen, first I will take curve of iron. Iron Fe plus O2 gives rise to 2FeO. Its delta G value is here 0 degree Celsius. This is the curve. Its delta G value is nearly 450 kilojoules per mole. That is negative minus 450. Okay. Next, same at 0 degree Celsius, we take carbon dioxide curve. So C plus O2 CO2. Then we will get delta G is equal to how much? Nearly this one, 350 kilojoules per mole. So listen, this is here. Nearly 350 kilojoules per mole. Not exactly I am telling, just approximate values. So here we want to check whether carbon reduces iron or iron reduces carbon. So first you assume carbon reduces iron. Okay, that means this is equation 1, this is equation 2. Okay, so here what happens?